All right. Well, good afternoon, everyone. A bit of a different style of delivery today. You have Mr. Schellenberg via video. We're going to do our formal in-class review. Tomorrow is a second review day. It'll be open tutorial style. Monday, we will start our next Trig unit, Trig identities, and then Tuesday is your test. So, diving right in. Things that you need to know for your test next Tuesday, minus this. You can cross off number 3. So all of our reciprocal trig functions, graphing them, we've taken it out of this unit. We looked at graphing secant and cosecant in our last trig unit. Okay, so here we go. We want to graph y is equal to 3 times the cosine of 2x minus pi over 2 minus 1. So the first thing I want to recognize is that this is not in factored form. And so our first step should be to factor it. So I'm going to factor a 2 out of the brackets. And what we would end up with is y equals 3 times the cosine of 2 times x minus pi over 4 minus 1. Okay, so there's the equation we're working with, and we can now go and set up the graph. So the first step here is we will relabel the x-axis as y equals q, which in this case is y equals -1. Our amplitude is 3, so our max value is going to be 3 above -1. So going up 1, 2, 3, we can call this 2. And our min value is going to be 3 below -1. So we can label this -4. Okay. The next piece to this is we want to graph our starting point. We have a phase shift of pi over 4 to the right. So let's just label this as being pi over 4. And this is a positive cosine function. Positive cosine function, we are going to start at a max point. Okay, so we have that. Now, the next phase here, or the next part of this, is we need to graph our significant points, or we need to identify what our significant points are. So we've got to take into consideration what the period of the function is. So the period t is equal to 2 pi divided by b. Here's our b value, it is 2. So our period is pi. Okay, we've had horizontal compression by a factor of 1/2. So it cuts our period in half. So the period of a basic cosine function, which is 2 pi, is now pi. Okay. So our horizontal scale, or the spacing of our significant points, we're taking the period, which is pi, and dividing that into 4 equal parts. Okay, so every pi over 4, we will have a significant point. Okay, so each of these boxes is going to represent pi over 4 units. So let's just, this would be 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4 is 2 pi, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4 is 3 pi, and that's probably enough for now. Okay, so it's a positive cosine function, starts at a max point, decreases to begin. So one significant point away, we have a mid, followed by a min, back to a mid, max, mid, min, mid, max, and so on. So we'll connect the dots. And there we go. We've got a couple periods of this function. Okay, it is a cosine function or sinusoidal function, so it is continuous. It will go on forever towards negative and positive infinity. Okay, so in light of that, if we're talking about domain, the domain of all sine and cosine functions, all real numbers. The range, okay, well, y is less than or equal to the max value, which is 2, and greater than or equal to the min value, which is negative 4. All right, let's flip the page. Next one, we want to graph y equals 5 times the tan of pi over 8 times x plus 3. The big difference here, we want to remember that the period of a basic tan function is pi. Okay, how does that impact our graph or impact our function? Well, our period formula changes. Our period formula is now pi over b instead of 2 pi over b. Okay, so we can go and set this up. First thing we'll do is relabel the x-axis. So we have a q value, or we don't have a q value. It is 0. So this is a true x-axis, y equals 0. And our max point, I'm just going to label this as being 5. I don't need to go up 5. And we'll label the min point as being negative 5. Okay, now our starting point is 3 units to the left. So we're going to go 1, 2, and 3 to the left. And tan functions start at midpoints. So I'm going to plot that starting point right there. Okay, now what is our period? Well, we'll use our formula here. So t is equal to pi over, and our b value here is right here, pi over 8. Okay, our period then is 8. And so what's the horizontal scale, or what's the spacing of our significant points? Take that period, which is 8, divide it into 4 equal parts, and we get 2. Okay, so I will add a few more notches here, and we'll just talk about some of what's happening as we go. Okay, so negative 3 is our starting point. Okay, negative 1 is 1 significant point to the right, and positive 1 is 2 significant points to the right. Negative 5 is 1 significant point to the left of where we started, and negative 7 is 2 significant points to the left of where we started. Okay, so trying to think about what the graph of our basic tan function looks like. We want to remember that 2 significant points on either side of where we begin are going to be vertical asymptotes. Okay, so at negative 7, I'm going to draw in that vertical asymptote. And at 1, we're going to draw in a vertical asymptote. Okay. 1 significant point to the right of where we start, we have a quote-unquote max point. And 1 significant point to the left of where we start, we have a quote-unquote min point. Okay, so there's everything we need, and we can connect the dots, and we will have graphed one period of this tan function. So there we go. Okay, so we'll add one more. 1, 2, this is 3, 4 and 5, 6 and 7, 8 and 9. Okay, so we have a vertical asymptote. The first positive one has the equation x equals 1. The period of this function is 8. So 8 units away from 1 is 9. We're going to have our next vertical asymptote. So, oops. So at 9, at x equals 9, let's draw in our next vertical asymptote. Okay, we'll add our significant points. We have a starting point at 5. We have a max point at 7. We have a min point at 3. And let's connect the dots. And there we go. So we've got 2 periods now of this tan function. And just a heads up to you, you will be asked to graph a tan function in the written section of your test next week. So make sure, I know we spend a ton of time with sine and cosine, maybe not as much time with tan. Make sure you are feeling confident about doing that. Okay, let's look at some of the properties of this graph. We'll do the range first. The range is y is an element of the real number set. And the domain, all of those vertical asymptotes are where the function is undefined. So our domain is basically just restricting where this function is defined. So we will say that x cannot be equal to, now the first positive vertical asymptote occurs at 1. Okay, and then it's every integer multiple of the period after that. Okay, so x cannot be equal to 1 plus 8 times n, and we'll specify that n has to be an integer. All right, moving on. So determine the following for the given equation. So we've got y equals -8 times the sine of 3x plus 3. Okay, so our amplitude here is, we think about that as being the absolute value of whatever a is. All the negative is telling us here is that this graph is reflected over the x-axis. But the amplitude is just 8. Okay, the period, t, is equal to 2 pi over b, and our b value is 3. Okay, there it is right here. Our b value is 3. The period is 2 pi over 3. Okay, range, so we've got to take into consideration the q value and the a value. So we're going to say that y is less than or equal to, now q plus a, 3 plus 8 is 11. That's our max value. And 3 minus 8 is -5. That's our min value. So y has to be greater than or equal to -5. Okay. Moving on. A little more challenging. We've got y equals a times the cosine of n pi over 5x plus b. Okay, what's our amplitude? Well, it's the a value. Okay, so we have an amplitude of a. Okay, what's our period? Okay, well, our period, t, is equal to 2 pi divided by b. And what's b? It is n pi over 5. Okay, if we work that out, we get a period of 10 over n. Okay, and our range. Okay, so y has got to be less than or equal to our max value. The max value is the vertical displacement, which in this case is b, plus the amplitude, which is a. So y has got to be less than or equal to b plus a, and then greater than or equal to b minus a. Okay. Moving on. So the next question says to determine the first positive value at which the following equation is a maximum. Okay, so determine the first positive value at which the following equation is a maximum. Okay, we are interested in knowing the period here. So let's take this first question here. The period is going to be 2 pi divided by b. Our b value is 2 pi over 8. The period, therefore, is 8. And if we think about that from a significant point standpoint, sig points, then our sig points occur every quarter of a period or every 2 units. Okay, let's give ourselves a brief sketch of what this looks like. So we have no phase shift. So our function's going to start at 0. It is a sine function. Sine functions start at midpoints. And I'll just jot down here, there's 1 full period. And if we break it up into 4 equal parts, then we've got 2, 4, 6, and 8. Okay, sine function, so it starts at a midpoint, and here's our answer here. 1 significant point away is our first max point. So determine the first positive value at which the following equation is a maximum. We can say that the max has coordinates. It's an x coordinate of 2. That's our answer. What is the y coordinate? Well, it's 3 plus 1, which is 4. Okay. Next one. So we want to work with the sine of 2x. Let's look at the period. T is equal to 2 pi divided by b. B in this case is 2. The period, therefore, is pi. And our sig points are going to be pi over 4. Okay, give ourselves a visual. Our period is pi. Break that up into 4 equal parts. This is pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4. Okay, it's a sine function. There's no phase shift, so therefore it starts at 0 and increases to begin. There's our first max point. So we can say that the max has coordinates pi over 4 is our x coordinate, and our y coordinate is just going to be 1. Okay. Increasing the degree of difficulty here. Our period, t, is equal to 2 pi divided by b. and b is 2 pi over 12. The period, therefore, is 12, and if we divide that into 4, our sig points occur every 3 units. Okay, let's give ourselves a visual. Now, we have a phase shift of 3 units to the left. So I'm going to go 1, 2, 3 to the left. This is a sine function. Sine functions start at midpoints. The problem is, or the difference is, this is a negative sine function. So where sine typically increases to begin, if this is reflected over the x-axis, then it's going to decrease to begin. Okay? So we've got a phase shift of 3 to the left. Our significant points, the period's 12 divided by 4, our sig points occur every 3 units. So we're going to have a min point at 0. And then let's go 1, 2, 3, 4, 5, and 6. Okay, so one more significant point to the right, we're back to a midpoint. And then finally our answer, one more significant point to the right, we have a max point. Okay, where does it occur? It occurs when x is 6, and what's y going to be? Y is going to be 1. Okay, and the last one is quite a bit more challenging. We're not dealing with numbers so much here as we're dealing with just different letters. Okay, so let's have a look at the period. The period is 2 pi divided by b. Now b in this case is a. Okay, what impact does that have on our scale, on our horizontal scale, or our sig points? Well, we're going to take the period, which is 2 pi over a, and we're going to divide that by 4, or you could think about that as multiplying by 1 over 4. And that would give us 2 pi over 4a, which simplifies to pi over 2a. Okay, so our sig points occur every pi over 2a units. Okay, let's give ourselves a visual here. Now, our phase shift is m, which means that this function is starting m units to the right. So I'm just going to make a little mark here to the right of the y-axis. I'm going to label this as being m. Now, this is a sine function. Sine functions start at midpoints. So we will plot that. And one significant point to the right of this, we will have a max point. What's it going to be? Well, it's going to be m plus that horizontal scale of those significant points, which is pi over 2a. Okay, so that next point is at m plus pi over 2a. It is a max point. So our answer here, the max, occurs where x is m plus pi over 2a. And what's the y coordinate there? It's just 1. Okay, q plus the amplitude, 0 plus 1 is 1. All right, moving along. Determine the equations of the asymptotes. So we've got y is equal to tan, the tan of 2x. So the big thing here, our period formula is pi divided by b, and our b value is 2. Okay, our sig points they occur in quarter periods. So we'll do pi over 2 divided by 4, or we'll just multiply by 1 over 4. So they occur every pi over 8 units. Okay, we'll give ourselves a bit of a visual. Okay, now tan starts at a midpoint at 0. We have no phase shift here. So there's where we're starting. And one significant point to the right is going to be pi over 8. That's going to give us a max point. Two significant points to the right is 2 pi over 8, or pi over 4. There's where our first asymptote occurs. Okay, so determine the equations of those asymptotes. We're going to say that x is equal to pi over 4. And then we need to add integer multiples of the period. Okay, the period is pi over 2, so we'll say pi over 4 plus n pi over 2, where n is an integer. Okay, on to the next one. Our period, t is equal to pi divided by b, and b in this case is pi over 6. Our period therefore is 6. Our sig points, we will take the period of 6, divide into 4 equal parts. Our sig points occur every 3 over 2 units. Okay, give ourselves a visual. We have no phase shift, so tan starts at a midpoint at 0. One significant point to the right, this is 3 over 2. And two significant points to the right is 6 over 2, which is 3. Okay, two significant points to the right is where our first vertical asymptote occurs. And from that, we can come up with the equation of our asymptotes. So we will say that x is equal to 3 plus integer multiples of the period, so plus 6n, where n is an integer. Okay. Give you just another second to digest that. Okay, next one. Y equals the tan of pi over 6 times x minus 1. Our period here is equal to pi divided by pi over 6. Our period, therefore, is 6, and our sig points, 6 over 4, is equal to 3 over 2. Now, give ourselves a visual. This time we have a phase shift of 1 unit to the right. It's a tan function, so we're starting at a midpoint. So there we go. Okay, now we're going to add one significant point, which is 3 over 2. Okay, so 1 plus 3 over 2, you can think about 1 as being 2 over 2 plus 3 over 2 is 5 over 2. And add another 3 over 2 to that, we get 8 over 2, which is 4. Okay, that's two significant points to the right of where we started. So that's where our first vertical asymptote will occur. and we'll use that to come up with the equation of our asymptotes. We will say that x is equal to 4 plus integer multiples of the period. The period's 6, so we'll say 4 plus 6n, where n is an integer. Okay, and then the last one here. So our period is pi divided by b, and b in this case is just b. Okay, our sig points. We'll take the period of pi over b. We will divide this into 4 equal parts, or multiply it by 1 over 4. So our sig points occur every pi over 4b units. And we'll give ourselves a visual. We have no phase shift, tan function, so we're starting at a midpoint. And we will add one significant point to the right is going to be pi over 4b. And if we add pi over 4b to that, we get 2 pi over 4b, which is really pi over 2b. And so that's where our first vertical asymptote will occur. And based off of that, we can come up with our equation. So we will say that x is equal to, now 2 pi over 4b, we'll just simplify that to pi over 2b. And then we are adding integer multiples of the period. The period's pi over b, so we'll say plus n pi over b, and we'll specify that n has to be an integer. All right. So moving on to a couple of word problems. And as we go through this, let's talk about some of the important information that's given to us. So a bicycle pedal rotates 30 times per minute. Okay, so we have 30 periods in 1 minute. What's the time for 1 period? That's 2 seconds. So t, or our period in this case, is going to be 2 seconds. Okay, the crank has a radius of 16 centimeters. The center of the crank axle is 28 centimeters above the ground. The pedal is in its top position at a time t equals 0. Okay, so top position, time t equals 0. If it's in the top position, I'm thinking that this is a positive cosine function. So we have y is equal to a times the cosine of b times x minus p plus q. Okay, so we want to determine what is a, b, p, and q. Okay, so a bicycle pedal rotates 30 times a minute. From that, we get that our period is 2 seconds. So our b value can be 2 pi divided by 2. Okay, yes, that simplifies to pi, but we're going to leave it as 2 pi over 2. Okay, the crank has a radius of 16 centimeters. The center of the crank axle is 28 centimeters above the ground. Okay, the center of the crank axle is going to be the midpoint of our graph. So our Q value is going to be 28. The radius is going to be our amplitude, which is 16. And the pedal is in its top position at a time of t equals 0 seconds. Therefore, we have no phase shift. Our p-value is 0. So draw a diagram to represent the height of the pedal above the ground for the first 6 seconds. Okay, so that's telling us it wants 3 periods of this relationship. So let's just draw a little graph here. We can label the x-axis y equals q. So this is y is equal to 28. Now 16 above that, we have our max point at 44. And 16 below that, we have our min point at 12. Okay, now we're told that the pedal is in its top position at a time of t equals 0 seconds. So we're starting up here at a max point. Okay, now we want to graph 6 seconds of this. The period is 2 seconds. So I'm just going to do this. I'll call this 2 seconds. I will call this 4 seconds. And I will call this 6 seconds. And let's break each of those up into 4 equal parts. And from here, we can plot the rest of our significant points. And we can connect the dots. And there we go. Okay, so the next part to this is write the equation for height, h, of the pedal at a time t. So we just need to plug a, b, p, and q into our formula. Okay, so height is our dependent variable h, so we get h is equal to, now this is a positive cosine function, so we have 16 times the cosine of, we've got 2 pi over 2. Let me just, we've got 2 pi over 2 times our independent variable t. There's no phase shift, so it's not t minus something or t plus something. And then our vertical displacement, which is plus 28. Okay, now at what time is the pedal first 25 centimeters above the ground? Okay, so this is an h value. H is equal to 25. Let's plug that into the formula that we just came up with, and we will solve for t. So we get 25 is equal to 16 times the cosine of 2 pi over 2 times t plus 28. And now we're looking to solve for t. Okay, so I'm going to bring the 28 to the other side. It becomes negative. 25 minus 28, we get negative 3. And I'm going to divide both sides by 16. Okay, that leaves us with the cosine of. Now at this point, it doesn't make a difference. We can simplify 2 pi over 2 to just pi. So we have the cosine of pi times t. Okay, how do we get rid of or undo the cosine? Inverse cosine. We've got to do it to both sides. So we're going to take the inverse cosine of negative 3 over 16, and this will be equal to pi times t. And from here, we can divide both sides by pi. t is then going to be equal to the inverse cosine of -3/16, all divided by pi. And that's a calculator question. Plug that in, making sure you're in radian mode. You should end up with t is equal to 0.56 seconds. Okay, and we'll do one more here. So the water wheel in the diagram rotates at 6 revolutions per minute. Okay, so if it can do 6 periods in a minute, how long does 1 period take? That's our t value, and that would be 10 seconds. Okay, so it'll take 10 seconds to go around once. That means we can do 6 times 10, 60 seconds. We can do 6 revolutions in a minute. Okay, when you start your stopwatch, point P is at the top of the wheel. Okay, so this is telling us a couple of things. When you start your stopwatch, okay, that means that time, t, is equal to 0 seconds, and point P is at the top of the wheel. That's telling me positive cosine function. So we've got y equals a times the cosine of b times x minus p plus q. Okay, so we want to determine what is a, b, p, and q. And we'll have to do some interpretation of the diagram here. Okay, now this right here is the center. I'll just sort of draw a circle around it. That's the center of our water wheel. Okay, yeah, you can think about that as being like the crank axle of the bicycle pedals. Okay, that midpoint, which we are told is 3 meters above sea level, that's our Q value. Okay, so Q is going to be 3. Okay, we can see that the radius of the water wheel is 4 meters. Okay, so our amplitude is going to be 4. And that tells us one thing here. That tells us that our min point is going to be below sea level. So it's going to be a negative height. So it's going to be -1 meter. Okay, now our b value is related to our period, so we're going to say 2 pi divided by the period, which is 10. And we have a phase shift, or we don't have a phase shift, it is 0. Okay, so the part A says draw a graph that represents the height of point P above the water at time t and draw at least 2 cycles. Okay, so let's draw a graph, and we can relabel the x-axis as y equals q, which in this case is y equals 3. Okay, now our max value, we're going to add the amplitude, so 3 plus 4, we get 7. And our min value, we're subtracting the amplitude, 3 minus 4, we get -1. So again, what does that -1 represent? That means we've gone 1 meter below the surface of the water. Okay, now when you start your stopwatch, point P is at the top of the wheel. So at 0 seconds, we have a max point. So we'll just plot our starting point. And it's asking for 2 cycles. Okay, so we'll label that. This is 1 period, so it's going to be 10 seconds. And we'll add a second here. This is our second period, which would be 20 seconds. And break each of these periods up into 4 equal parts. And we can plot the rest of our significant points. and connect the dots. And there we go. So part A is done. We've drawn 2 cycles of the relationship here between height and time. Okay, so the next one is write the equation for height above the water at a time t. So we need to plug A, B, P, and Q into our formula. This is a positive cosine function. So we get h is equal to 4 times the cosine of, this is 2 pi over 10 times t plus 3. Okay. Now find the height after 3 seconds. So that's a t value, a time of 3 seconds. We will plug that into the formula that we just came up with in the place of t. So we get h equals 4 times the cosine of, we have 2 pi over 10 times t, so we're substituting 3 in for t, and then we're adding 3. And just one more reminder, so I'm just going to put a set of square brackets around all of this. This is our theta in radians. Okay, think of that as being your angle. So as you're punching this into your calculator, you need to make sure you're in radian mode. Do the cosine of, now 2 pi over 10 times 3, that's like 6 pi over 10. So do the cosine of 6 pi over 10, hit equals, multiply that by 4, hit equals, and add 3. And you should get, if I can read my writing here, should get 1.76 meters. Okay. Okay. And the next one here, find 2 times at which the height is 2 meters. Okay, so this is an h value of 2. So let's plug that into our formula in the place of h. So we get 2 is equal to 4 times the cosine of 2 pi over 10 times t plus 3. And we're looking to solve for t. Moving the 3 over to the other side, we get 2 minus 3 is -1, and -1 divided by 4 is -1 over 4, is equal to the cosine of 2 pi over 10 times t. We will take the inverse cosine of both sides. So we've got the inverse cosine of -1 over 4 is equal to 2 pi over 10. Just give myself some more space here. From here, we can multiply both sides by 10 and divide both sides by 2 pi. So we're going to get that t is equal to 10 times the inverse cos of -1 over 4, all divided by 2 pi. Okay, and what you should get is 2, whoops. Where'd we go? Okay, what you should get is 2.9 seconds. So the question is asking, find 2 times at which the height is 2 meters. Okay, I'm going to call this T1, or time 1. The first time that our water wheel, or point P on the water wheel, is at a height of 2 meters is at 2.9 seconds. Now, to find a second time, the easiest thing to do, we'll call it T2, would be to just add a period. Okay, so we've got 2.9. We're going to add the period, which is 10 seconds. And so we get 12.9 seconds. Okay. All right, now the last part to this is a tricky one. During each rotation, how long is point P below the water? Okay, so below the water, one thing that we have to recognize here is that sea level, or the surface of the water, is at a height of 0 meters. Okay, if our height is positive, that means we're above the water. If our height is negative, it means we're below the water. And if the height is 0, that is the surface of the water. Okay, so the first thing we're going to do is calculate the first time at which the height is 0 meters. So let's plug 0 into our formula for h. We get 0 is equal to 4 times the cosine of 2 pi over 10 times t plus 3. 0 minus 3 is negative 3. Negative 3 divided by 4 is equal to the cosine of 2 pi over 10 times t. Let's see if we can do this all in one step. T is equal to, this is going to be 10 times the inverse cosine of negative 3 over 4, all divided by 2 pi. Okay, and what we should get here is 3.85 seconds. Okay, we will call this time 1. Okay, now to answer this question, let's go back up to our graph up here. Okay, let's get a little more information. The water wheel in the diagram rotates at 6 revolutions per minute. When you start your stopwatch, point P is at the top of the wheel. Okay, so here's what we've determined. Here's point P. So the time it takes to get from there all the way to the surface of the water is 3.85 seconds. Okay, so 3.85 seconds to there. Now, what we're looking for here is this. How much time is point P underwater? Okay, and that's what I've done in red. So it enters the water at 3.85 seconds. At what time does it exit the water? Okay, well, let's do this. Okay, let's say that this right here, that's got an x coordinate of 3.85, which is our time, so at 3.85 seconds. The y coordinate, which is height, is going to be 0. Okay, now this is where we can use our significant points. Our min point here, well, that's half a period. So it's going to be 5 seconds. Okay, how much time is between 3.85 seconds and 5 seconds? Well, that's 1.15 seconds. So we're going to have the exact same thing over here. So 5 plus 1.15 seconds is going to be 6.15 seconds, and that's the second time that our height is at 0 meters. Okay, so the question is, during each rotation, how long is point P below the water? Okay, well, we can do, what did we have here? 6.15 seconds, 6.15 seconds minus 3.85 seconds. And so we should end up with 2.3 seconds underwater. All right, and that is it for today.